Welcome to Study Loop.
This is the answer to Chapter 13, problem number 47 from the Smith Organic Chemistry textbook. And this problem tells us that treatment of benzoic acid with sodium hydroxide followed by 1-iodo-3-methylbutane forms molecule H. And then we're given some information about molecule H. It has a molecular ion at 192. And it has these 4 IR absorptions, and we are asked to propose a structure for molecule H. So I guess by this point in the book, we haven't learned the carboxylic acid reactions yet, but this is very clearly the formation of an ester. I'll do that at the end. We'll solve this using just spectral data at first, and then we can confirm it just by knowing the reaction. So the M to Z of 192, so we can start to guess how many carbons, hydrogens, and oxygens we have. The ring should not be affected by this reaction. And so that's going to account for 6 carbons. And then we have the carbon that's part of the carboxylic acid in our starting material. So that's 7. And then if we assume that we're going to add this entire 1-iodo-3-methylbutane in some way, that's going to be 1, 2, 3, 4, 5 more carbons. So that's a total of 12 carbons. And so 12 times 12 is going to be 144. So that's 144 of our 192. As I said, I don't think either of those oxygens is going to go anywhere. So we can say there's going to be 2 oxygens. So that's going to be another 32. So 144 and 32 is going to be 176. And so 192 minus 176 is going to leave us with 16 hydrogens. So I'm going to propose a formula of C12H16O2. And we can calculate an HDI for that formula. And so it's going to be 2 times 12 plus 2 minus 16. So 24, 26 minus 16 is 10. Over 2 is 5. So an HDI of 5. And so, of course, as I said, I don't expect the ring to be affected. And so that's going to account for 4 of our degrees of unsaturation. And then, as I said, I expect this to produce an ester. And so there is our 5th degree of unsaturation. So far, this agrees with my prediction of an ester. So then we need to look at the IR data. And so this peak at 1721 is going to be due to a carbon double bond oxygen. And the rest of these peaks are going to be due to C sp3H bonds and C sp2H bonds. So again, so far this agrees pretty well with my prediction. And I'm going to say that the rest of the molecule looks like this. As I said, later we'll learn the reactions of carboxylic acids. And so basically this is going to go like this reaction. So we have our benzoic acid. This is going to be deprotonated by the sodium hydroxide. And then that oxygen with a negative charge is going to act as a nucleophile and just displace the iodine on this 1-iodo-3-methylbutane. And so it will attack this carbon. The iodine will leave. And so we will end up with this ester. Okay, Oh, I think I missed something here. 1, 2, 3. Oh, no, that's right. But I drew it wrong here. Okay. Okay. What have I done? 1, 2, 3, 4. Yeah, there we go. Okay. Yeah, and so that's going to be the answer. Oh, 1, 2, 3. Yeah, so I drew it wrong here. That's what the problem is. Okay, my apologies. So 1, 2, 3, 4. So this is going to be our product. And so we can get there using this spectral information, and then knowledge of this reaction itself is going to provide a way to double check. And so this is the correct answer here. And again, that's how I would approach this problem. Use the M to Z and what we know about the starting material to try to figure out a formula, calculate an HDI for that formula, see if it makes sense with our prediction thus far, and then look at the IR data for further confirmation. And then again, if you do know the particulars of the reaction that you're considering, you can certainly predict the products and use that to double check. And that's the answer to chapter 13, problem number 47.